Game Dev Journey. In today's video, we're going to be demonstrating how to shoot where the mouse cursor is and aim in the different directions and firing a bullet or a laser. So make sure you've got the assets downloaded in your folder, and let's get right to it. We'll start with the bullet scene. So we'll add a new node. This will be an area 2D, and we'll rename it to bullet. And we'll add a collision shape, a sprite, and a visible on-screen notifier as children. It's collision shape 2D, add a sprite 2D, and a visible on-screen notifier 2D. Now for the sprite, you can go ahead and add the laser.png as the texture, and we can scale this because it's going to be quite big. So go to the transform and set the scale to 0.3. While we're here, we may as well set the texture to nearest. We can also use the collision shape, and I would recommend a capsule shape here, which we can rotate 90 degrees, and we will just make it fit, stretch it a bit. Yeah, that looks about right. Now that we've got the bullet set up, let's add a script to the bullet. So you select the bullet node and you select add script. Bullet is a good name, and we're in. Let's give the script a class name. So let's say class name bullet extends area 2D. Let's add some variables for the speed and the damage. So export speed be an integer, and let's say 200, and export damage, and let's say it does 15. Those can be adjusted later. We also need a variable for the direction the bullet is heading in, and by default we'll set it in the right direction because that's where it's pointing. So this will be a vector 2, and we'll make it equal to vector2 dot right. Now let's create a function to set the direction of the bullet, because the gun could be pointing in a different direction and we need the gun to tell the bullet which direction it's facing. So let's say function set direction, and we'll have bullet direction, which is a vector 2, and this method doesn't return anything, so it's void, but we do set the direction to the bullet's direction, which is the direction received from whichever function calls this. And then we need to set the rotation of the bullet to the bullet's direction dot angle. Now that's a really useful function, built-in function of Godot, this angle, because Godot's default forward in the 2D engine is 0 degrees along the x-axis, so that's right. So angle is the angle function calculates the angle between the positive x-axis, which is right, and the vector that you provide, which is bullet direction. So the result, by setting rotation equal to bullet direction dot angle over here, you're telling the bullet turn from facing right until you face the direction that you're moving. So for example, if the angle is 0, so we're currently facing right, then rotation is 0 because you're already facing right. But if you're moving down and the angle is 90 degrees, then the bullet has to rotate clockwise 90 degrees. But if you're moving left, then the angle is 180 degrees, So the bullet must flip to face the left-hand side. So in the physics process, so if we go function underscore physics process, all we really need to do is update the position of the bullet. So we're going to say position is going to be equal to direction multiplied by our speed and multiply by delta for smoothing. Now we need to connect the body entered signal of the bullet so that it damages the enemy and destroys itself. So yeah, let's actually get rid of this free space here. So if we click on the bullet and we go to node signals, we find body entered and we connect it. So when a body enters the bullet, we're going to say if the body dot is in group, and we'll look for an enemy group or enemies or something like that. So if it hits an enemy, we want to call the get damage function on that enemy, which we haven't made, of course, because there is no enemy yet anyway. I don't even know if we'll make the enemy in the script, because really, I mean, in this tutorial, it's really just to demonstrate shooting in different directions. And then we can destroy the bullet itself, so we free it there. The other thing we should do is use the visible on-screen notifier to destroy the bullet once it leaves the screen, so that we don't keep bullets alive in memory when they're not even visible on the screen. So we can connect the screen exited signal over here, and all we need to do is call QFree again. So QFree. So the bullets will be destroyed once they go off screen. Save the scene, and now let's do the gun scene. So let's create a new scene here. We'll use node2d as the root. Let's call it gun, and let's add a sprite and a marker and a timer. So we've already got our sprite here. We can use a marker as well and a timer. Here we go. So the question you might ask yourself right now is, why should we use a node2d for the gun? Well, generally physics bodies, physics actors, players, enemies, bullets, if an object moves via physics, using collisions, gravity, velocity, then that root node must be a physics body. So if you make, and why? Because if you make a node 2D the root, and then you put a character body 2D inside it, when you call move and slide, the child will move away, but the root is going to stay at the top left corner at 0, 0. So you're going to get weird errors happening because your game logic, such as position and calculations, will think the object is at the starting point, but the visual sprite is actually far away from it. For user interfaces, if you're making a menu or a health bar or an inventory or so on, then generally always you're using one of the control nodes or some kind of container, like a VBox container or something. Because Node 2D doesn't have anchors or margins. So if you're using Node 2D as a root for your user interface, then you're not going to be able to resize it correctly. It's not going to look good on different screen sizes and so on. So when should you use a general Node 2D as the root? Well, for almost everything else, especially composite objects, generic Node 2D is the right node to use because it's ideal for weapons and tools, guns and swords and flashlights, or static objects, trees and signs and chests, for visual effects like explosions and spells, and for spawners like enemy spawners, checkpoints, and so on. So using a Node 2D allows you to treat the object as a container, and you can then swap the art, which would be the sprite, change the audio, the audio stream player, or add particles, and you don't break the logic on that root node. Okay, so that's why we're using a no 2D as the gun. So let's grab the sprite for it. So if we choose the sprite, we're going to get the texture here. So let's choose our laser gun, pull it in, and there's our gun. It's very small. So what we can do is if it's very blurred, so let's change our texture to nearest so we can get those sharp edges. And let's well, before we decide if we need to scale it or not, let's see what it looks like when we add it to the player. So let's just leave it size-wise. Let's leave it for the moment, but let's put the marker at the point of fire where the bullet will launch from. So if we click on the marker, we can move it to the muzzle. So I would say somewhere there, somewhere. If you want exact reference, it's 19 pixels, should be fine. You can move it closer, depends where you want the bullet to come from. But that looks pretty good to me. Alright, let's add a script to the gun. So if you select the gun, click on add script. Gun is a fine name, click on create. Again, let's give it a class name. So class name gun. It's perfect. Let's give an export variable for the shoot speed. Export bar shoot speed. That can be a float, and we can make it equal to 3.0. Right, let's add a constant for the bullet scene. So let's go bullet and make it equal to a preload, so I can spell it right, and it will be the bullet scene. There we go. We could also add this as an export variable, which is probably a better way to do it, because you could move the bullet scene in your folder, put it inside another folder or something, and then this would break. Whereas if you made it an export and you had to set it in the inspector, then you would always have to drag it up there. The path would always be correct. Okay, let's add some onReady variables for our marker, our timer, and our sprite. Let's just rename this timer over here the cooldown timer, so that you can't just spam shots. It has to cool down. Right, so let's add our sprite. So we want the marker, so drag, hold, control, and release. We want the timer, so drag, hold, control, and release. And we want the sprite itself, drag, hold, control, and release. Now we've got references to all of our things that make up the gun. Okay, so let's add another variable. Let's add a variable called canShoot, which will work with our timer. That'll be a bool, and we'll set it to be true at the start. And let's add a variable called bullet direction, and that'll be a vector 2, and we'll set it to vector2.right. Okay, perfect so far. Now let's create a function to set the direction of the gun, and then to set the bullet to point in the direction that the gun is facing. And of course we also want to rotate the gun to point in that direction. And because we might rotate through a full 180 degrees, the gun's going to turn upside down, and in that case we need to flip the sprite so that it doesn't appear upside down. So let's call this variable, this function, set direction, and it will receive a direction which is a vector 2, but it doesn't return anything. It's going to be void. Now the bullet direction will be equal to the direction of the gun. So the rotation of the gun will be equal to the direction of the gun dot angle. And just like we did for the bullet, this will make sure that the gun is facing the direction it's pointing in. Okay, So our sprite, if it gets rotated 380 degrees, is gonna flip upside down, and so we need to turn it back in the right, so it's the right direction. So we flip the vertical, and we make it equal to direction dot x less than 0. Okay, so this function does two jobs. It updates the logic, so it saves the direction for the bullet over here, and it updates the visuals, because if the gun has rotated 380 degrees, so its x direction is less than 0 now, because it's gone in a semicircle to the left there, it's going to turn upside down. We need to flip it if it turns upside down. So quite a useful function over there. Okay, so let's now connect the cooldown timer to allow the gun to shoot only after a slight delay, so that you can't just spam shoot. So if we click on the cooldown timer and we go to the node, we connect the timeout function and we click connect. All we need to do is set can shoot to true over here. So we go can shoot equals true. Now we can decide on how fast the timer can shoot. If you click on the inspector here, the wait time, this is how long it will be between shots. So let's do 3 seconds between shots, and see what happens, see what that looks like when we try it. Okay, actually maybe we should set this in code, because we've got shoot speed over here 3, and what that means is we shoot 3 bullets. This can actually be an integer. I'm going to change this. Oh no, it needs to be a float. Okay, but this is actually going to be how many bullets we shoot per second. So we should actually leave this timer on 1 second, because what we'll do is we'll divide this wait time by the shoot speed, and that's how many bullets you can fire per second. Let's do it in code and you'll understand. Right, so let's create a function called shoot. And all it does is shoot, so it's void. Okay, so if you can shoot, right, currently, then you will shoot, and then can shoot will toggle to false. Now you can't shoot, okay, because you've just shot. So now we should update the wait time. So let's say the cooldown timer dot wait time is going to be equal to, like I said, that 1 second divided by shoot speed. Okay, and then you start the cooldown timer. You restart it. Dot start. Okay. What do we need to do? We need to create a bullet. So var bullet is going to be equal to, we've got our constant at the top of the bullet scene, so it's going to be the bullet scene dot instantiate. That creates a bullet. Now we need to put it in position, so we need to say let's go to the next line. We need to say bullet dot global position is going to be where that marker is, the marker 2D dot global position. We want to fire from the muzzle of the gun. Then we want to make sure it goes in the right direction. So we're going to say bullet dot set direction, and we've already calculated that because we've got bullet direction. And then we want to add it to the current scene. So we want to say get tree, right, dot current scene dot add child, and we want to add the bullet to the scene, to the current scene. Okay, that should make the gun shoot the bullet correctly. So let's save this as the gun scene. Now we need a player to hold a gun and shoot a bullet. So let's make a new scene, Because it's a player, we'll use a character body 2D. So let's search for character body 2D. There we go. Okay, let's add a collision shape and an animated sprite. So we'll go with collision shape, and let's have animated sprite. Animated sprite. There's an animated sprite. Okay, there we go. Animated sprite is going to need new sprite frames, so let's create some and load them up down here. Maybe for the purposes of this demonstration, we don't actually need to do all of the character animations. But what you could do is grab them from this idle sprite sheet over here. So let's call this one idle down. If you go and choose the sprite sheet, there's idle over there. Open it. We got 1, 2, 3, 4 by 4. 4 by 3. So it's going to be something like that. And so if we're going down, looks like it's the middle one here. We add those 4 frames. Okay. And then you'd have to go and do, idle left, idle right, idle up. You'd have to add all these other ones in to do it. The sprite looks very tiny. Let's change its texture straight away to nearest. So we get that, and let's scale the sprite up as well. I would scale it up by 3 times. So let's say 3. It's a nice, much bigger sprite. Okay. I'm not going to go ahead and do all the animations. At least we've got something to see. That's enough for this tutorial. Let's add a shape, a collision shape. So I think a rectangle is fine. Let's just put it in front so I can see it. And just size it so it's covering our player. I think that's fine for now. Okay, let's add a gun to the player. Okay, I'm just going to move the collision shape to the back again so that we can see the player. Let's add a gun. So I'm going to drag the gun scene into the player scene like this. Drag it in and release it. There it is. Okay. And now I'm going to position the gun in the player's hand, sort of thing, something like that. Right? Looks like he's holding the gun. Okay. Now let's just check the gun's shoot speed is 3. Oh, what's our position over here? We've got about 10. Maybe we want to move it in a little bit more. What if we said 7? Yeah, more central. No, that looks good. Okay, now let's do the script for the player. Okay, so let's save the player scene. Let's rename this to player. Okay, let's save the player scene. And now let's add the script to the player scene. Player name is fine. Okay, let's add a class name again. Class name player. Okay, let's add a constant for the speed of the player. It can be a float and make it equal to 300. Now let's add an onReady variable for the gun. So let's drag that gun in and hold Control and release. There's our reference to the gun. All of the action happens in the physics process function. So let's get that going. Function underscore physics, and there we go. First thing we want to do is handle the shooting. So if they're pressing the shooting key, we call the gun's shoot function. So we're going to say if input.is action pressed, and we'll take UI accept, that's a spacebar. Then we're going to say gun.shoot. Okay, so that's the shooting done. Now we'll do the movement. So we can get the direction they're moving in, the vector they're moving in, by using the getVector function that's built in. So we can call it a variable called direction, which is a vector 2. and we make it equal to input dot get vector, and we're going to say left, right, up and down. So UI underscore left, UI underscore right, UI underscore up, and UI underscore down. That'll get us the vector, the direction vector we're moving in. Now we can apply that movement by saying if we've got a direction, then we set our velocity to the direction multiplied by the speed. Now, if we're only going to update the gun direction if we're moving, so that it can remember the last direction that we were in. So we're going to say if there's a gun, then we're going to say gun.set direction to direction. Otherwise, we're just going to instantly stop. So we're going to say velocity is going to be equal to vector2 dot 0. And then we must remember to call move and slide. Okay, let's test this, and the easiest way to test this is to create a level with a node 2D as the root, and then just instance your player in the level. So I've just created a level and dragged the player here into the middle. So when we run this as the main scene, we can shoot in the correct directions. If I press up and I shoot up, down and shoot down, left, down and left, up and right, up and left, down and right, and all the other directions. I can shoot in all the directions. Okay. Now, what if I wanted to make a twin stick shooter where I control the movement with the keys on the keyboard, but I shoot in wherever I click the mouse, wherever I'm shooting the mouse on the screen? Let's see how to do that part of it. Okay, so this is, instead of passing the movement direction to the gun, we'll calculate the direction from the player's position to the mouse cursor on the screen. So let's make a fire command. So if you go to project settings, and we go to the input map, let's add a new action called fire, and let's add the action for it to be let's add a new action called fire, and let's add the action for it to be left mouse button. So when I click the left mouse button, that will fire the gun. Now let's go back to our move and process function in the player script. Okay, and after move and slide, let's do our what we'll call mouse aiming. Okay, so firstly we need the mouse position. So let's go var mouse position, and that's going to be get global mouse position. Now let's get our direction from the player to the mouse, and we do that by subtracting the mouse position, or subtracting the player's global position from the mouse position, and then we normalize it. So we're going to say var the look direction is going to be equal to our mouse. Right, so the look direction is going to be equal to the mouse position minus the global position, and then we're going to normalize it, dot normalized. Now we need to update the gun. So we're going to say if we have a gun, we're going to say gun dot set direction to our look direction. And now we can do the shooting. So let's do shooting. So we can say if input dot is action pressed our new fire action, then the gun must shoot. So gun dot shoot. Okay, so now the question you might be asking yourself, which I am asking, is why are we doing all of this after the call to move and slide? I thought move and slide is generally meant to be the last call. Well, for shooting, we actually want to be pretty precise. So by moving first, and then ensuring that we calculate the aiming angle, we're doing it from the player's final position, not the position they were in the previous frame. So this makes the aiming more snappy and accurate. Okay, so let's see how this looks in the main game. So we run it. Now as I move the gun, you can see the gun spinning. And if I shoot there, as I shoot in the different directions, you can see that the player shoots, and I can move and shoot at the same time. And the bullets are really slow. I mean, we would have to speed this up, but you can see that it works. You can shoot in all the directions. Okay, well, I hope that this was useful, and I'll see you next time.